Okay, so today we are going to be talking about solving one-step inequalities. One step. All right. So what is an inequality? An inequality is a math sentence using the less than, greater than, less than or equal to, or greater than or equal to signs. Okay? So that's different than an equation. An equation has a equal sign. Equation has an equal sign, which means it has a definite answer or only one answer makes the equation true. In an inequality, multiple answers make the inequality true. There's only one number that makes the equation true, but there are multiple numbers that make the inequality true. Okay, so an example of an inequality would be k plus 3 plus 1 is less than negative 2. This is an inequality. An equation would be k plus 3 plus 1 equals negative 2. So this is going to have one number as an answer, and we can go ahead and solve that equation. So k plus 3 plus 1 simplifies to k plus 4 equals negative 2. Again, we can bring this 4 to this side and say k equals negative 2. When it switches sides, it switches signs, so this positive is going to turn into a negative over here, 4. Okay, so we can say k is going to equal negative 2 minus 4. Negative 2 in the negative direction 4 would be negative 6. Okay, so k in an equation it only has one answer. Okay, but let's see what happens with the inequality. When we solve this, we're going to solve it the same way. We're going to pretend like this less than sign is an equal sign. Okay, so we're going to just pretend that that's an equal sign, and we're going to use that as our dividing between the two sides. Okay, so k plus 3 plus 1 is less than negative 2. All right, so let's simplify this left side of the less than sign and say k plus 1, or 3 plus 1 is 4, is less than negative 2. Okay, so k plus 4 is less than negative 2. We can bring this over to this side with the negative 2. And again, when something switches sides, it switches signs. K is less than negative 2 minus 4. It was a positive over here. It's a negative over here. Okay? And we're going to end up with k is less than negative 6. All right? We have the same answer number-wise, negative 6 and negative 6, but this says k is less than negative 6, and this one says k is equal to negative 6. So in the inequality over here, this is the inequality because it has the less than sign. Okay, this is an equation because it has an equal sign. All right, in the inequality over here, we have a negative 6 and a less than sign. K is less than negative 6. That says that k can be any number less than negative 6. Would be negative 7, negative 125, negative 1,032 would all make this equation, or I'm sorry, inequality true. Okay? So just to prove to you that any number less than negative 6 could be k, I'm going to plug a number in here, and I'm going to say k plus 3 plus 1 is less than negative 2. And I'm going to substitute a number in, and I'm going to say negative 8 plus 3 plus 1 is less than negative 2. Okay? Negative 8 plus 3 is what? It's negative 5. Plus 1 is less than negative 2. Negative 5 plus 1 is negative 4 is less than negative 2. Is that true? Yes, it is. Okay, now, again, the inequality has the less than, greater than, less than or equal to, and greater than or equal to signs. Okay, now we're going to graph on a number line. Okay, we're going to graph this inequality on a number line. So we have the inequality k plus 3 plus 1 is less than negative 2, and I've solved it out, all right? And we simplified, and we got k is less than negative 6. So a number line is exactly that, a line of numbers. So I'm going to look at this. This is the number we're working with. We're working with negative 6. So for now, I'm just going to put negative 6 close to the center. All right, and I'm going to put some numbers on each side. So I'm going to go down on this side, negative 7, negative 8, negative 9, negative 10, negative 11. And on this side, I'm going to go up the number lines, so negative 5, negative 4, negative 3, negative 2. We're getting greater in numbers as we go. All right, so the number that we're looking at is negative 6. So I'm going to put a circle around negative 6. Is k equal to negative 6? This is the less than sign. Does it say less than or equal to? No, it doesn't. Okay, so could k be negative 6? No. K could not be negative 6. K does not equal negative 6. All right, that doesn't work. So for less than or greater than, we're going to leave the circle open. For less than or greater than, we're going to leave the circle open. All right, so the circle is open. It's not filled in, all right, because k cannot equal negative 6. But k can equal all the numbers less than negative 6. So I'm going to shade in the left of the circle, left side, okay, going down the number line. Number lines don't have to be neat. They just have to serve the purpose of the graph here. So we're graphing on a number line. So k is any number less than negative 6. So negative 6 is not part of the answer, but negative 6.5 is. This is where negative 6.5 is, negative 7, negative 8, negative 9, negative 10, and so on, down to negative infinity. It all works for this inequality. Okay, let's look at another one, all right? M is, we're going to make that a negative m. Negative m is less than or equal to, it's half a less than sign and half an equal sign. Less than or equal to 5. This one seems pretty simple, okay? So one thing to remember is that when we have a negative m, any variable, any letter, all right, that just has a negative in front of it, we can put a 1 there. So negative 1m, because there's only one of them. All right, negative 1m is less than or equal to negative 5. Okay, now we want to do an inverse operation. An inverse operation, okay? An inverse operation, which means an opposite operation. Okay? An inverse operation is an opposite operation. So we have, this says negative 1 multiplied by m is less than or equal to 5. So what is negative 1 multiplied by m's opposite? What is the opposite of multiplication? Division. Okay, so I'm going to divide each side by negative 1, because what you do to one side, you have to do to the other side. Okay, so these negative 1's cross out, and I'm just left with a positive m. And I have a negative 5, or a 5, I'm sorry, divided by a negative 1. which is negative 5. Okay? Now, we need to remember one more thing here. This is very, very, very important. This is very, very important. When we divide or multiply by a negative number, we need to flip the inequality sign. So did we divide by a negative number? We divided by negative 1, so we need to flip the inequality sign. So this is wrong. This m is greater than or equal to negative 5 is correct. So we need to flip right here. We're going to flip this, and it's going to turn into a greater than sign. Okay, if that doesn't make sense, rewind and watch it again, but we will do another example. Okay, so let's graph this. M is greater than or equal to negative 5. So let's make a number line. Okay, so we're working with negative 5, so I'm going to put it about in the center, and I'm going to go negative 4, negative 3, negative 2, negative 6 on this side of negative 5, negative 7, negative 8. Okay, so we're working with negative 5, so I'm going to circle negative 5, and I'm going to say, okay, it could be negative 5 because it's equal to negative 5, so m could equal negative 5. So since m could equal negative 5, I'm going to shade the circle in, all right, and I'm going in the greater than direction. So greater than is the positive direction. I'm going in the positive direction. So negative 4 is greater than negative 5, so I'm going to shade everything to the right. Trying to be as neat as you can, but it's not going to be perfect. Okay? Now this is a completed inequality problem. Okay, I have the number line graphed. I have an inequality answer. All right? I have solved and graphed this inequality. Again, remember, for less than or greater than signs, leave the circle open. But if there is a less than or equal to or greater than or equal to, you need to fill the circle in, just like this. Okay? Negative 24 plus a is less than negative 6. Okay? Negative 24 plus a is less than negative 6. So I'm going to try to combine like terms. Are there any like terms on this side? No, there are not. This is the only term on this side. So what can I do? I can put this 24 over on this side, all right, to get the a by itself. We always want to get the variable by itself. So a is less than negative 6. When it switches sides, it switches signs, plus 24. So what is negative 6 plus 24? A is less than 18. Okay? So a could be any number less than 18. All right, so I want to graph that. Let's make a number line. Put 18 around the center. Go up a couple numbers, 21, 22. Go down a couple numbers, 17, 16, 15, 14. Okay. So a is less than 18. So we're working with 18. I'm going to circle 18. Now, remember, the circle does not get filled in if there's not a less than or equal to sign. If the sign were like this, the circle would get filled in, but it is not. So the circle does not get filled in. All right? So a is less than 18. So I'm going to go in the less than direction, the negative direction, which is to the left. So I'm going to shade all this in. So this tells me that a could be 17, 16, 15, 14, 13, negative 2, negative 5, or 1. Okay? So any number less than 18 would make this inequality true. Let's do another example. Negative 5 is less than or equal to k divided by 4. Okay? So we want to look for inverse operations. So we want to get the k by itself. So the k is being divided by 4. So what is the opposite of dividing? Multiplying. Okay? Multiplying is the opposite of dividing. So I'm going to take this side and I'm going to say multiply by 4. Okay? And I'm going to, what you do to one side, you have to do to the other side. Multiply by 4. Okay? 4 multiplied by negative 5 is less than or equal to k multiplied by 4. So these 4's are going to cross out. And 4 multiplied by negative 5 is negative 20. And all I'm left with on this side is a k. So negative 20 is less than or equal to k. All right, that's pretty simple. That's only one step. That's one step. All right? Okay, so next we need to graph it. All right, so let's make a number line. And let's put negative 20 near the center. Let's go negative 20, 19, negative 18, negative 21, negative 22, negative 23, negative 24. All right, so we're working with negative 20. So I'm going to circle negative 20. Now it is less than or equal to negative 20. So negative 20 could be a solution to the problem. Okay, so I'm going to fill that in because it is less than or equal to. Okay, if it is less than or equal to, it gets filled in. All right, or if it is greater than or equal to, it would still get filled in. Now, less than, I'm going in the left direction. Less equals left. All right, so we're going to fill this in. And we're done. That is the inequality. Okay, we're going to do one more inequality example. All right, negative 12c is less than or equal to negative 56 minus 4. Okay, so this says negative 12c negative 12 multiplied by c is less than or equal to negative 56 minus 4. So right off the bat, we can just simplify this side because we know that we can subtract 4 from negative 56. So we can say negative 12 multiplied by c is less than or equal to, what is negative 56 minus 4? It is negative 60. Okay, negative 56 go in the negative direction, 4 negative 60. Okay, so now we're going to do an inverse operation. Okay, what is the inverse operation of negative 12 multiplied by c? The inverse of multiplication is division. So we're going to divide both sides by negative 12. These negative 12s cross out. And what is negative 60 divided by negative 12? It's going to be 5. Okay? But we divided by a negative. So what do we do? This is important. If we don't flip this, it's wrong. So this is going to get flipped, and it's going to turn into c is greater than or equal to 5. Okay, if we don't flip the sign, the inequality will be wrong. Okay, we divided by a negative, so we flip the inequality. If we multiply by a negative, if this is multiplication, instead of division, we still flip the inequality because it's negative. Okay, so now let's graph it. All right, we're working with 5, so put 5 near the center, and then 6, 7, 8, 9, 4, 3, 2, 1. Okay, so we're going to put a circle around 5. All right, and then we're going to go in the positive direction. Positive is right. Greater than is right. Greater than 5. C could be any number. It could be 6, 7, 8, 9, or 10, or 11, or 12, or 150, or 1,203, whatever. It doesn't matter. Okay? So any number greater than 5 makes this equation true. But does 5 make it true? It says C is greater than or equal to 5. So yes, it does. 5 could be C. So we're going to fill in that circle. All right, and we're done. Okay? A couple of things to remember. Okay? First of all, you want to combine the like terms. All right? Look for combined like terms that you can combine, okay? This is going to be a little more complicated a little bit later on, so we're going to look for like terms to combine. When you divide or multiply by a negative number, the inequality switches, okay? The inequality switches. Another thing, graphing on a number line represents all possible solutions. So make sure the circle is filled or not filled correctly. And look for inverse operations, opposite operations, okay? You want to get the C by itself or the X by itself. You want to get the letter by itself. So if there's a 5x, all right, is less than 15, the inverse operation would be division, because this says 5 multiplied by x is less than 15. So I'm going to divide both sides by 5. The side crosses out. Those 5s cancel each other out. X is 15 divided by 5, which is what? 3. Okay? So inverse operations, what's the opposite of division? Multiplication, what's the opposite of addition? Subtraction, what's the opposite of subtraction? Addition. You want to look for these inverse operations to get the letter by itself.